Hello guys, I am Nidhi Bagalwadi, your science teacher, Sankalp Learning Solutions. In the last class, we discussed regarding the carbon and its compounds, and we discussed mainly the chemical properties of a compound, right? Chemical properties of a carbon compounds. First, we discussed regarding combustion, next oxidation, next addition and substitution. As well as we discussed two more important compounds of the carbon, ethanol and ethanoic acid. So in that we have to concentrate on two main reactions. The first one is esterification, the next one is saponification. Esterification, where it is used to prepare the esters which are used in perfumes, as well as we can say for flavoring the substances. And the next one that is saponification, which is used in the production or a preparation of a soap, right? So this is about this concept, carbon and its compounds. In this chapter only, we have another, we can say, part where we are going to learn the saponification reaction in detail in the preparation of soaps and detergent. Let us proceed to it, guys. So we know that soaps and detergent are our basic needs, right? So both we will use for the cleaning purpose. One is for clean our body, for to clean the utensils and the clothes. The other is for to clean the clothes, right? So soaps and detergent, how these are made? The first slide goes, we will read the slide first. So the molecule of a soap are sodium or potassium salts of long chain of carboxylic acid. So it tells what is soap actually, what is detergent actually. So the soap, the first we will talk about soap. What is it? Chemically, what it is? It is made up of sodium or potassium salts, which will be having long chain of carbon with the carboxylic acid. What is the carboxylic acid? It's a functional group that is COOH. It is its symbol formula. The ionic end of soap dissolves in water while the carbon chain dissolves in the oil. So we know that it is made up of carbon chain along with the acid, right? So the ionic end, the end which has a ion or a charged particle, it dissolves in a water. And the other end which has a carbon chain, it will dissolve in a in a oil. The soap molecule thus forms structures called micelle. So what are micelles? We will see in the next slide. So they form a structure which is called as micelles, where one end of molecule is towards the oil. One end will be towards the oil. The other end will be towards the water or outside. This forms an emulsion in a water, emulsion kind. The soap missile thus helps in dissolving the dirt in water, and we can wash our clothes clean. So this makes the dirt to dissolve in a water, right? And then the clothes will be get cleaned. So as you can see, this is a glycerol, right? When it reacts with the base, we will get sodium salt, okay, sodium salt. So this is a sodium salt which we got. This is nothing but a soap, right? Natural soaps are prepared by boiling lard or other animal fat with sodium hydroxide. So this reaction is called as saponification, soap formation, right? So here you can see the ionic end, okay, which dissolves in a water. The other end will be there. Now, this end will dissolve in a oil, right? This is called micelle. Mechanism of the cleaning action of soap. So let us see what is the process. Their long hydrophobic hydrocarbon chains are insoluble in water and tend to cluster in such a way to minimize their contact with water. Hydrophobia, hydro means water, phobia means fear. So the long chains of hydrocarbon which are present in the soap, they will not attract water, they will be away from the water. So they are insoluble in the water, and they try to not to contact with the water. They're polar hydrophilic. One more end it will be having, which is called hydrophilic. Hydro means water, philic means love. So these end will be having love towards the water. So these always tend to remain in contact with the surrounding water molecule. Driven by these two forces, one end is water hating, the other one is water loving. So these two ends form a cluster, a group which is called as micelles. Okay. So as you can see, this is a charge end which is hydrophilic, love towards the water, or a polar head. This is the uncharged end which is hydrophobic. So like this, many this one are formed which are called missiles. Okay, a soap missile. It is a non-polar hydrophobic hydrocarbon. Non-polar hydrophobic. Non-polar hydrophobic hydrocarbon chain cluster in the inside. Cluster. These are hydrophobic cluster in the inside, and polar carboxylate groups lie on the surface. So charges lie on the surface, hydrophobic ends lie inside. They group together inside. This is called soap missile. Okay. Next. So missile means what? It is a spherical arrangement of organic molecule. Means the molecules will arrange spherically in water, clustered so that their hydrophobic parts are buried inside. Hydrophobic parts are buried inside, whereas the hydrophilic parts will be outside or towards the surface, which is in contact with the water. So this forms a spear-like, which is called missile. So here you can see hydrophilic and love towards water, hydrophobic and hate towards water. Next, let us see the procedure. When soap is mixed with the water, this is a soap, this is a water, right? When soap is mixed with the water, insoluble grease, oil, fat, whichever there in the on the what we can say cloth, the non-polar parts of a soap missiles means the hydrophobic part of a soap missiles will dissolve in these grease, oil, fat, etc. Non-polar dirt molecule, and they are carried away with a polar wash water. And this all will be carried away with the polar end of the wash water. Right. Then soap forms water insoluble salts when used in water containing calcium to magnesium to this one. So they will say that don't use the soap in the hard water. Why? Because hard water will be consisting of the elements like calcium, magnesium, etc. So when these elements react with the soap, water insoluble, when these elements react with the soap, okay, along with the water, they form a salt which are insoluble in water. So you can see a patches on the clothes when you wash the cloth in a hard water with the soap. That is why we should not wash this cloth in the hard water using the soap. It is due to the formation of insoluble salts. Okay. Then the molecules of detergent. So what are these detergents are? These are sodium or potassium salt. These are also sodium and potassium salts. So their soaps were long chain of carbon. Here it will be long chain of sulfonic acid. I'm sorry. It will be long chain of sulfonic acid. This is a sulfonic functional group. They do not form water insoluble salt when they will used in a water containing, means they are not what we can say they will not come in contact, or they don't have any influence of the hard water. They can be used in a hard water. Fine. Okay. So this is regarding the soaps and detergent concept of the carbon and its compounds. So here we completed the concept of carbon and its compounds. In the upcoming session, we are going to start with a new lesson of chemistry. Until that, take care. Have a nice day. Bye-bye.